Hello, this next video in a playlist that I'm calling Complex Variables, where we're creating a playlist on complex analysis. We're in the background material part of this playlist, and specifically trigonometry. And today's topic is we're going to find the amplitude of the sum of the sine and cosine functions, which is essentially this function here. We're going to try to find the amplitude of it. But we're going to reference two background videos. I'm going to call them cv10 and cv11. This stands for Complex Variables Playlist, video 10 in that playlist, where we look at the period, phase shift, vertical shift, amplitude, and frequency. CV11, so it's the playlist Complex Variables, the 11th video, and it's the sine and cosine of the inverse tangent function. We're going to use two methods to find the amplitude of this time series. And let's go. The first one is a trigonometric approach. So let's let xt equal, a times the cosine of omega t plus b times the sine of omega t. Now we're going to use algebra at first. We're just going to multiply it by a well-chosen one, specifically the square root of a squared plus b squared, right? If we multiply this in, we're just left with a times the cosine of omega t. And the same way here, we're left with this. We get it back. Now some more algebra. We can take this and rewrite it in this form here. And I'm going to let you do the math on that, but those are equivalent. Everything else comes down. This fraction can be rewritten in this form. And the reason we do that is because, and I got to scroll back up a second. So in CV11, we derive the formula for the cosine of the arctangent of this angle B divided by A, which is this right here. So that's what we replace it by. The sine of the arctangent of B divided by A is this fraction here, and we derive it in that CV11. But then we're left with the cosine times cosine plus sine times sine, which is a famous it's a trig identity of the cosine of the difference of two angles. So we just do it in reverse. So we have a number times the cosine of an angle. Well, which clearly has an amplitude of the square root of a squared plus b squared. And I'm going to point you to video CV10 to show you why that is the amplitude of this function. But that means it's the amplitude of xt. And so we're finished. Now let's use a more calculus-based approach to find the amplitude of this function, or the sum of cosine and sine. Let's take the derivative of xt, and I'm going to flash back up a second. So we're going to take the derivative of this. Remember, the derivative of cosine is minus sine. The derivative of sine is cosine, and then we take the chain rule, and that's what this is. We get minus a times the sine of omega t. The chain rule with respect to t, would you get omega back, plus b times the cosine of omega t times omega. And this is with the chain rule. We set it to equal 0. Right? So we set this equal to 0. We can add that to the other side, do some division, and we get the sine over cosine, which is tangent, is equal to b over a. We can take the arctangent, or the inverse tangent, to both sides, and then divide by omega, and we get t is equal to the arctangent of b over a divided by omega. Now what we've just derived, and so t indicates where the minimum or the maximum occurs. Now to find the actual value, we have to plug t back into xt to find the values. Okay. So we take t, and I'm going to scroll back to the top again, and we plug it back into this. So we plug in t. Notice the omegas cancel instantly in this. And we're left with this. So xt is equal to a times the cosine of arctangent of b over a, and plus b times the sine of arctangent of b over a. Well, in CV11, we derive the formula for the cosine of the arctangent and the sine of the arctangent, and that's what these are. Notice the plus or minus because these could be positive or negative. We do some simplification, so we get a common denominator here, invert, multiply, we get this. Well, we can add these two fractions, and then the denominator goes into the numerator once, and we're left with this. Okay, so this is the maximum and the minimum values at those specific t's. So, and these are the minimum and maximum heights. Okay, which is what the amplitude is. So this shows that the amplitude is the square root of a squared plus b squared. And that's what we wanted to show, two different approaches. Well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.